students, in the last video, that is our coordinate geometry part 1, I have given in the derivation of the distance formula, a very simple derivation. It is given line segment, say AB is equals to under root x2 minus x1 the whole square plus y2 minus y1 the whole square, and simple 2-3 problems I hope I have solved to give a just idea about the distance formula, how we can measure the distance between the two given coordinates. Now, as I told in the previous video, there are plenty of varieties of problems you will come across in this chapter coordinate geometry. And today let us solve some more problems. Okay. See, in my last video, whatever problems I have solved, this is a given line segment AB. The coordinates are given, x1, y1, these two will be given to you, x2, y2 will be given to you, and you will find what is the distance. This is one type of problem we have solved. I will slightly modify it. Find the value of m. Find the value of m if distance between 3m and 4,1 is square root of 10. Look at this problem. Look at this problem. Okay, what is given? Distance is given. So in my earlier case, distance you have found, whereas coordinates are given from my end. x1, y1, x2, y2, both are given to you, and you have found the distance. Now the problem is slightly different. What they say? This is a given line segment. I will call it as AB. The distance between the coordinates of the point are 3m and 4,1. The distance is given to you. The distance is square root of 10. The distance is square root of 10. And your work is to find the value of m. Same formula. Let me apply. AB is equals to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay? Which is equals to under root. No need to write x1, y1, x2, y2. You remember this. Okay? This you can call it as x1, y1, or this you call it as x1, y1. That makes no difference. Come on. Ultimately, this minus this plus this minus this. Very simple. Okay. AB is given root 10. Root 10. AB is root 10 is equals to x2 minus x1 the whole square. 3 minus 4 the whole square. 3 minus 4 the whole square plus y2 minus y1 the whole square. See, I have told you x1 y1, x2 y1. Or x2 y2. x1, that makes no difference. So it is 3 minus 4 the whole square or 4 minus 3 the whole square plus m minus 1 the whole square, which is equal to. Now what happens? This is also square root, this is also square root. I can cancel the square root on both sides, and I can write 10 is equals to 3 minus 4 the whole square. Square root has got. I have removed the square root here. Okay. 3 minus 4 the whole square. In the last video, after seeing the video, one of my students has commented, "Sir, why can't you use here a minus b the whole square? Why can't you use a minus b?" I want to tell him, listen to me. Here, m is an unknown. In this case, a minus b the whole square formula has to be applied, because I don't know what is the m minus 1, what is the value of m minus 1. But here, when both are the known numbers, no need of applying a minus b the whole square. The value is known. 3 minus 1 is minus 1. Minus 1 the whole square is 1 plus, here m is an unknown. So no other go for me. I have to use a minus b the whole square. That means a square. M square minus 2ab. 2 into m into 1 plus 1 square. Okay? I can simplify. 10 is equals to m square minus 2m. 1 square is 1. 1 plus 1 is equals to 2. I can shift this that side. Okay, and I can write what? 0 is equals to m square minus 2m plus 2 and minus 10. Minus 10. What happens? Everything is right? 3 minus 4? m minus 1. 4 and yes, x2 whole square, y2 minus y1 whole square. M square minus 2m plus 1. It is 1 plus 1, 2 minus 2. Okay, it is m square minus 2m minus 8 is equals to 0. Okay, if you multiply, you should get 8. If you subtract, you should get 2. If you multiply, you should get 8. On subtract, you should get 2. 4 and 2 are the middle terms. 4 and which 4 and which 2? Minus 4 and plus 2. I can put 1m before this and 1m before this is equals to 0. Therefore, m minus 4 is equals to 0. m plus 2 is equals to 0. Therefore, m is equals to minus 4. Sorry, m is equals to plus 4 or m is equals to minus 2. My dear children, it's a problem of a coordinate. It can be negative, it can be positive. See, if you go to second quadrant, x is negative. If you go to third quadrant, both are negative. If you go to fourth quadrant, y is negative. So that will not make a difference for us. But which is the m value you are going to choose? My dear children, both are the right answers. Both are the right answers. And again, I will tell you verification part. Those who are interested, they can check it. How? Put the value of m. Put the value of m as 4. Put the value of m as 4. You forget this. Root 10 is there. You forget this. Take these two coordinates and find the distance. Your answer must be root 10. Check it. Or now you put the value of m as minus 2. Now your coordinates are 3 minus 2, 4, 1. Again you can find the distance using the distance formula. Your answer must be root 10. Check it. Okay. Let me go for one more. Let me go for one more problem. Okay. Show that the coordinates 3, 0, 6, 4 and minus 1, 3 form an isosceles triangle. Isosceles triangle. Look at this problem, students. This is one second type of problem I have completed. Now I am going for the third type of problem here. Show that it is an isosceles triangle. That means now the distance formula has to be applied 3 times. Here we have applied distance formula only once. Now so you have to prove that it is an isosceles triangle. So what I will do? I will just draw a small rough figure for my reference. I will call it as ABC. Listen very carefully. This is in the examination 3 marks question. Very simple. Very simple. Come on. I will write here 3, 0. Anyway, you can take 6, 4 and what? Minus 1, 3. Minus 1. What am I going to do now? I will find the length of AB using the distance formula. Using these two coordinates, you are getting one answer. I am going to find the length of BC. You are getting one more value here using these two coordinates. And you are going to find the length of AC using these two coordinates. That means distance formula has to be applied thrice. And somewhere you should get 2 measurements must be same. Either these two or these two or these two. When 2 lengths are same, we can call it as an isosceles triangle. Come on. Let me start. AB is equal to under root. I am not going to apply the formula now. Directly. This minus this, this minus this. Or this minus this, this minus this. That will not make any difference. Anyway, you can start. Come on. AB is equal to. I will start from here. 6 minus 3 the whole square. 6 minus 3 the whole square. Plus 4 minus 0 the whole square. 4 minus 0 the whole square. Which is equals to under root 6 minus 3. 3. 3 square. 9 plus 4 minus 0. 4. 4 square. 16. Answer is square root of 25 units. Square root of 25 units. This is one length we got. We got the length of A. If you want, you can write it as 5 units. Answer is 5 units. No problem. I will go for BC. Length of BC I will start. Length of BC I will start. See? This minus this. Or this minus this. No difference at all. 6. But don't make the mistake in writing the sign. 6. 6. Minus of minus 1. See? x2 minus x1 the whole square. 1 minus from the formula. 1 minus from the number. 2 minus will come. Minus of minus 1 the whole square. You should not be in confusion. Why this 2 minus have come? 1 minus from the formula. Solve it in the bracket. There is one value is negative here. Okay. Plus 4 minus 3 the whole square. 4 minus 3 the whole square equals. Come on. Minus of minus is plus. It is 6 plus 1 the whole square plus 4 minus 3 is 1 is 1 square. So it is 7 square 49 plus 1. Answer is square root of 50 units. Oh, they are different. That means this must be either root 50 or this must be under root 25. Then only I can say they are it is an isosceles triangle. Come on. I will know what I am going to get. AC. Let me find the length of AC. This minus this or this minus this. Anyway you can do it. Okay. 3 minus of minus 1. 3 minus of minus 1 the whole square plus 0 minus 3 the whole square. 0 minus 3 the whole square. Come on. Which is equals to under root. Minus of minus is plus. 3 plus 1 the whole square. 3 plus 1 the whole square plus minus 3 square. Any negative number when you square it, it will be positive. It is 9. Which is equals to under root 4 square. 16 plus 9. Answer is under root 25 units. Root 25? Root 25? I can write AB is equals to AC, which is equals to under root 25 units. Therefore, triangle ABC is isosceles. Triangle ABC is isosceles triangle. Look at the students, this is a problem where they ask you, show that these three vertices form a right angle isosceles triangle. Now work is little bit more now. See, in my earlier problem, I have shown it is an isosceles. Now apart from isosceles, it has to be proved it is a right angle also. How to do it? So anyhow, you got one more chance to solve it as an isosceles triangle. That means you can pause the video. You can try up to show that it is an isosceles triangle. And definitely you will get two sides are equal. And later I will tell you what is to be done. Okay? Come on. Let me draw a small figure. I will call it as PQR. I will call it as PQR. This is 7, 10, minus 2, 5, and 3, minus 4. Come on, one by one. Let me go for PQ first. PQ is equal to under root. PQ is equal to under root. Okay. 7 minus of minus 2. 7 minus of minus 2 the whole square plus 10 minus 5 the whole square. 10 minus 5 the whole square. Which is equal to under root. Minus of minus is plus 7 plus 2. 7 plus 2 the whole square plus 10 minus 5 is 5. 5 square is 25. Which is equal to under root. 9 square. 9 square. 81 plus 25 Answer is 106 units. The length of PQ we got root 106 units. Let me as it is. No need to convert in decimals. Okay. Let me go for QR. Let me go for QR under root. This minus this or this minus this. Anyway, minus 2 minus 3. Minus 2 minus 3 the whole square. This minus from the formula 3 directly. Always 1 meter minus will come from the formula x2 minus x1 the whole square. Come on. 5 minus of minus. 5 minus of minus 4 the whole square. Which is equals to under root. Come on. Both are minus. Keep the minus in as it is. Add the numbers. Minus 5 the whole square. Minus 5 the whole square. Plus. Minus of minus is plus. 5 plus 4 the whole square. Come on. Under root. Minus 5 square. 25. Plus 9 square is 81. 81. Answer is square root of 106 units. 106. See, already got both answers are same. That means it is isosceles. Even when I have to go for the third side, PR. I have to go for the third side, PR. Come on, under root. Under root. Anyway, this minus this. This minus I go from here. 3 minus 7 the whole square. 3 minus 7 the whole square plus minus 4 minus 10 the whole square. Minus 4 minus 10 the whole square. Which is equals to under root. 3 minus 7. 3 minus 7. Minus 4. Minus 4 square. 16. Minus 4 square is 16. Plus. Minus 14. When both are minus, keep the minus in as it is. Add the numbers. Minus 14 square is 196. 196 gives you under root. Under root. It is 296 not 6. Yes. Minus 206 or 216 it is. Yeah, it is 260. PR is equals to 216 units. My dear children, if you do up to here, what you have proved? You proved that it is an isosceles triangle. But you have to prove along with that what is required. You have to prove it is a right angle triangle. So you may say no, sir, I will go with a Pythagoras theorem. Yes, Pythagoras theorem. How? What I will do, these things have to be kept in mind. What I will do, I will find the squares of all the three sides. I will write PQ square is equals to, whenever they ask you to prove it as a right angle triangle, all the three values has to be square. Because you know that Pythagoras theorem, the square of the hypotenuse is equal to sum of the squares of the other two sides. Sum of the squares of the other. That means everything has to be square. Come on, PQ square. PQ square. It is square root of 106 the whole square. Root and square gets cancelled. Answer is 106. PQ square. I will go for QR square. QR square. Again, square root of 106 the whole square. Answer is 106 units. 106 units. See, square and square gets cancelled. 106. Last one, PR square. PR square is equals to square root of 216 the whole square. Square gets cancelled. Answer is 216 units. What Pythagoras theorem says? The square of the hypotenuse. No doubt, my dear children, biggest will be the hypotenuse. Biggest will be the hypotenuse. Hypotenuse. Square of the hypotenuse is equal to sum of the squares of the other two sides. 106 plus 106 is equals to 216. No, somewhere. Oh, wrong. 6 plus 6 is 12. It is 212. 212. Yes, see how we can easily identify the mistake. See, 106 plus 106. 212. 212. That means this square square plus this square. See, this square is here, this square is here. On and you are getting this answer. That means PQ square plus QR square is equals to PR square. I can say which are the two sides equal? PQ is equals to QR. I can say here PQ is equals to QR, and this is for isosceles. And what? PQ square plus QR square is equals to PR square. Since square of the hypotenuse is equals to sum of the squares of the other two sides. See, 1 or 6 is equal to 212. This square is equal to this square plus this square. Therefore, triangle PQR is right angled isosceles triangle. Right angled isosceles triangle. See the addition. This is the way the problem has to be solved for right angled isosceles triangle. Okay. We'll go for a last problem. With that, we will close our discussion. Come on. One more. See, we have completed isosceles. We have completed right angled isosceles, and we'll go for one more problem. Come on. Show that the points 4, 2, 7, 5 and 9, 7 are collinear. Okay, are collinear. Come on. Yes, are collinear. What do you mean by collinear? Collinear means the points must be on the same straight line. If the two or more points, if three or more points lie on the same straight line, then the points are called as collinear. Now, how we can prove this? See, I will take one point as A, one point as B, one point as C. Okay? I want to prove that if they are collinear means I should find the length of AB, I should find the length of BC, I should find the length of AC. If AB plus BC is equals to AC, AB plus BC is equals to AC, or adding any two. If you are making a third side, for example, I am making AB is equals to 5. Example will be BC is equals to 6, AC is equals to 11. See, AB, BC, AC. 5 plus 6 is equals to 11. That means AB plus BC is equals to AC. That means the points are collinear. No need to square it. If you square, it will be a right angle triangle. If you remove the square, it will be a collinear. What right angle triangle says? The sum of the squares of the two sides is equal to the square of the third side. If you square it, is the answer for right angle. If you don't square it, just AB, BC, AC, adding 2 if you are getting the third side, then it is a collinear. Come on, let me solve the problem. Okay, I will tell the coordinates of A 4 and 2, coordinates of B 7 and 5, coordinates of C it is 9 and 7. Come on. I will find first length of AB. Length of AB and we start under. See, very easy. This minus this, or this minus this. Anyway, you can start. 4 minus 7 the whole square. 4 minus 7 the whole square plus 2 minus 5 the whole square. 2 minus 5 the whole square. Under. 4 minus 7 minus 3 minus 3 square plus 9 plus 2 minus 5 minus 3 minus 3 square again 9. So root 9 plus 9, root 18 units. We got the first length, AB cleared. We go for BC. BC is equals to under root BC. This minus this minus this. 7 minus 9 the whole square plus 5 minus 7 the whole square. 5 minus 7 the whole square. Come on, under root. 7 minus 5. Minus 2. Minus 2. Minus 2 square. 4. Plus. How much? Minus 2. Minus 2 square is 4. Root 4 plus root 4. It is root 8. 4 plus 4 is 8. Root 8 units. We want the second answer. What the third? It is AC. Length of AC we are finding under root. AC. 4 minus 9 the whole square. 4 minus 9 the whole square plus 2 minus 7 the whole square. 2 minus 7 the whole square. Come on. Under root half. 4 minus 9. Don't make mistake. 1 plus, 1 minus. Bigger number minus, smaller number. 9 minus 4, 5. Minus 5 the whole square. 25. Plus 2 minus 7. Again minus 5. Minus 5 square. 25. 25 plus 25. Square root of 50 units. After reaching up to here, the child says, sir, the problem is wrong. Problem is wrong because 1 is root 18, 1 is root 8, 1 is root 8, 50, nothing you can add, nothing you can add. And what I told you, to prove it, it is a collinear, add any two, you should get the third answer. Not by squaring, don't square it, as it is. AB, BC, AC. Out of those three answers, add any two, you should get the third answer. Unfortunately, root 18, root 8 on adding, no. Then what is the technique? What is the technique? This is very, very important whenever there is a problem of collinear. These are things you have to keep in mind, then only the problem can be solved. Collinear means you should keep in mind, simplify the answer. Right angle means you have to remember, square the answer, simplify. My dear children, simplify means you may say 18, 6 3s are. You should split in such a way that one must be a perfect square, one must be a non-perfect square. Can I write it as a 9 2s are? 9 2s are? Yes. Here only I have given some space here. I can write it as 9 2s are. So answer is 3 root 2. 3 root 2. See, square root of 9 is 3 root 2. Likewise, can you split this as 4 2s are? Under root 4 2s are. Square root of 4 is 2. It is 2 root 2 units. 2 root 2 units. Can you split this? Very easy. 25 2s are. Don't say 10 5s are. I have told you should split in such a way that one must be a perfect square, one must be a non-perfect square. Write it as 25 2s are, and the answer is 5 root 2 units. Now you see, by adding 2 are you getting the third answer? Yes, definitely. See, 3 root 2 plus 2 root 2, answer is 5 root 2. Very simple. 3 root 2, just like algebra. This is what is a surds. It is addition is like algebra. 3x plus 2x is equal to 5x. I can write 3 root 2 plus 2 root 2 is equal to 5 root 2. That means AB plus BC is equal to AC. Therefore, points A, B, C are collinear. See students, we have solved some problems today. This is not the end. There are again plenty of examples, but based on the same formula, little bit technique has to be remembered. Collinear, answer is to simplify. right angle triangle, the answer should be square. These things have to be kept in mind. And we'll stop our session here. And when we meet tomorrow, we will solve again plenty of examples based on distance. Okay, students? Till then, goodbye. Take care.